Generators are the heart of any power plant. But what protects them from faults and failures? That's where generator protection relays come in. In this video, we'll explain what they are, why they're important, and the most common types, in simple terms. Think of a relay as a security guard for your generator. Its job is to monitor electrical signals like voltage, current, frequency, and temperature. When something abnormal happens, the relay sends a trip signal to a circuit breaker, disconnecting the generator before damage occurs. Generators are expensive and critical. They need protection against overcurrent, overvoltage, undervoltage, frequency problems, internal short circuits, loss of excitation, reverse power, and unbalanced loads. Here are the most important relays. Overcurrent relay, ANSI 50/50 firsts, trips on high current. Overvoltage and undervoltage relays, 59/27s, keep voltage safe. Frequency relays, 810/81U, protect against speed changes. Differential relay, 87G, detects internal winding faults. Loss of excitation, relay, 40, trips if the magnetic field is lost. Reverse power relay, 32, prevents generator from acting as a motor. Negative sequence relay, 46, protects against unbalanced load currents. Think of each relay as a specialist doctor for your generator. One monitors current, another voltage, another frequency. If anything goes wrong, the relay instantly tells the breaker to trip, isolating the generator. Imagine a 10 MW generator running. If lightning strikes the line, the overvoltage relay trips. If a short circuit happens inside the windings, the differential relay acts. If steam supply drops and the turbine slows, the underfrequency relay trips. Generator protection relays are like the immune system of your power plant. They continuously check for problems and act before damage occurs. Without them, a single fault could destroy a generator worth millions. Subscribe for more electrical engineering videos.